In the last bunch of videos, we've been filling out these reference sheets, the Cartesian plane formula reference sheet and this quadrilateral proving reference sheet, the conditions that you need for a quadrilateral to be a parallelogram, a rectangle, a rhombus, or a square. And so what we're going to do now is we're going to take a look at the kinds of problems that we can tackle with all of this information laid out in front of us. Let's take a look at this problem. So here I've got a Cartesian grid and I've got these 4 points here, and I want to prove that this quadrilateral ABCD is a parallelogram. All right, so this isn't like a proof that I've got some given statements. The only things that are given are these points in this diagram. Okay, so what information can I pull out of this diagram that's going to help me to solve this problem? Well, for each of the 4 points, I know its coordinates. So here's my origin. So A is 1, 2, 3 points over and 1 point up. B is 5, 6, 7, 8 points over and 2 points up. C is 10 points over and 6 points up. And finally, D is 5 points over and 5 points up. All right. And so now that we've got these sides, now that we've got these coordinates, let's think about how the information in these sheets can help us. All right. So what do I need to do to prove that a quadrilateral is a parallelogram? Well, I could prove that it's a parallelogram if I could show that the 2 top sides are parallel and the left and right sides are parallel. Do I have enough information here to calculate whether those sides are parallel? What kind of tool would I need in order to do that? I've got one of these formulas. Which one is going to help me to figure out if 2 line segments are parallel to each other? Figure out if line segments are parallel, I want to calculate the slopes of those line segments. And so given these coordinates, I can calculate the slope of this line and the slope of this line. If they're the same, then these 2 lines are parallel. And if these 2 lines are parallel, then, if those 2 lines have the same slope, then they're parallel as well. And if those 4 sides are in 2 sets of parallel sides, then that's a parallelogram. Another thing I know is that if the opposite sides are congruent, then that's enough information for me to tell that it's a parallelogram. Do I have a formula that lets me calculate whether line segments are congruent? Yeah, that's why we spent some time focusing on the distance formula. And we'll skip over the 3rd one. The 4th reason here is that the diagonals bisect each other. Okay, so how can I figure out if these 2 bisect each other? Once again, is there a formula that I have that's going to help me with that? Oh my gosh, that's the midpoint formula. Okay, so that's why we've been studying the slope formula, the distance formula, and the midpoint formula, because it's going to help us figure out about parallel, perpendicular, congruent, and bisected line segments. And the reason we're interested in those things is because those are the conditions that we need to prove that quadrilaterals are parallelograms, rectangles, rhombuses, and squares. All right. In the next few videos, we will go through each of those formulas and show how it can help us show that this quadrilateral is a parallelogram.